Hello, my name is Robert Camano, Head of Solution Engineering at NetFoundry. And today I'm going to demonstrate how to create a LAN gateway from an OpenZiti Edge router for the purpose of transporting data between non-Ziti aware endpoints across a Ziti fabric. I've created this diagram to depict the demonstration, and I've created a Ziti network that comprises of a OpenZiti transit router and an OpenZiti controller. We'll be adding two edge routers to act as LAN gateways, one for the 172.16.31.0 subnet, and another one for the 172.16.240 subnet. On the 172.16.31.0 subnet, we have a Windows 10 client, and on the 172.16.240.0 subnet, we have an Ubuntu server. The edge router's name for the 172.16.31 subnet is local router with an IP address of 172.16.31.173. And the edge router that is providing LAN gateway services on the 172.16.240 subnet is remote router. Both routers are built on Ubuntu 22.0 for server. With that, we will now take a look at the commands that we are going to issue on each of the routers, which are almost identical except for IP addresses, the name of the router, and the role attributes assigned to the identity for the tunneler function on that router. So the first three commands are to set up UFW on the LAN interface of the router. So first we enable it, then we allow DNS, and then we allow SSH. DNS is to allow the Windows client to make queries to the Ziti router for Ziti hostname-based services. And SSH is enabled to allow us to connect to the router in order to both configure the router and enroll it in the OpenZiti network. The next command injects the Ziti router's resolver address into the systemd resolved global DNS resolver list. We do that with DNS equals 172.16.31.173 injected into etc systemd resolve.conf, and then we restart systemd resolved to make the changes take effect. Next, we download the Ziti binaries, we untar them, then we make a subdirectory called certs, which will have the router store its certificates and keys for authentication to the OpenZiti network. Next, we're going to log into the controller using our API user, API password, and the CA certificate, public certificate for the Ziti net. Next, we're going to issue the Ziti Edge create edge router's name -T flag to say that we want to enable the tunneler function so that we can act as a LAN gateway. And we're using the -O option to save the enrollment JWT to the local file system. Next, we use the Ziti router binary to enroll the router using its config YAML and the enrollment JWT that was just created in the previous command. Finally, we edit the identity for the tunneler function that is created as a part of the router due to the -T flag, and we set a role attribute for it, and that role attribute we are setting is clients, And we'll use that when assigning this to a dialer service policy. With that, we're going to go ahead and take a look at the config YAML for the local router. Expand our window so we could see the entire config file. So the first key that we're going to look at is the identity key, which has several subkeys, which essentially just tells the router where to store its certificates and keys in the file system. And it also uses those to locate them when it has to authenticate to the Ziti network. The next section or the next key is Edge, and under there is a subkey CSR, where we have the CSR parameters that will be used to enroll the Ziti router into the OpenZiti network. And under the SAN section, we set the IP address to the local LAN interface of the router. The next key is control, CTRL, and the subkey endpoint. This sets the fabric control listener that we are going to connect to on the controller with the IP address of the controller and its port. Next is the link section, which is used for creating links between routers. In this case, this router is going to only be a dialer, so it will be dialing outbound towards the Ziti fabric, and it will not be a link listener, so it'll be running in dark mode. That's the case for both routers. We're the only link listener router in this network is going to be the existing Ziti transit router. The next key is listeners. And under listeners, we have binding key edge. And here, the address key is going to be set to set the all interfaces to listen for the edge function on port 443. And then under the options key, we are going to advertise the local private LAN interface of the Ziti router and its port 443. The next binding key is tunnel. This key combined with the -T option when we created the router together configure the router to support tunnel function and act as a LAN gateway. The next important key under options is resolver, and this tells the Ziti router what address to use as its resolver for hostname-based Ziti services, which here we set to the local LAN IP address of the router. And then we have the DNS service IP range, which is the range of addresses that Ziti uses to bind hostname-based services to. And that's in the range of the 100.64.0.0/10, with the first IP address being 1. The final key here is LAN IF, which is set to the LAN Interface's Linux interface identifier, which in this case would be ENS33. This is used to have Ziti create IP tables rules that are specific to each service to allow those services to actually ingress through the LAN interface. So those will be the only rules allowed in addition to the UFW rules that we created earlier. One thing of note is these rules will not show up under UFW. Those will only show up using IP tables in order to display those rules. All right, we'll close out of that configuration. We'll take a look at the remote router. As I mentioned, the commands essentially are all the same. Only changes are to the IP address, then also the name of the router when we enter the Ziti Edge create edge router. And then we also are changing the role attribute to hosts in this case, as this router's identity will be acting as the hosting identity for the service that we are going to create. So before we go ahead and start the configuration, I'll just go over quickly. We're going to be creating a service from the Windows 10 client across the OpenZiti network for SSH to allow it to SSH across the OpenZiti fabric to the Ubuntu server at 172.16.240.129. So with that, I'm going to go ahead and run a helper script that is going to run through all the commands that we went over and configure the local router. Okay, as you can see, UFW is enabled. Rules were added for DNS and SSH. Print out those rules so we can see them, that they're in place. We're now downloading the ZD binaries. Untarred them, logged into the controller, created the router, enrolled the router, set the role attribute for the identity associated with the router, added the resolver to the global resolver table, and then we displayed the global resolver table here, as you can see, which is showing in the global section with the ZD router's IP address, LAN interface. Okay, we're going to go ahead and do the same for the remote router. Okay. Now that that's complete, we're going to go ahead and start the router. Before starting the router, the local router, we're going to go ahead and run another helper script that is going to go ahead and configure our services. And we'll go through the commands as that completes. Of note, you'll see after creating the service that the remote router is now hosting a newly available service called SSH. And that has also established a terminator for that service. So quickly, we will go through the commands that were issued. We logged into the controller. We created an intercept v1 config with protocols TCP. This and address is mysimpleservice.ziti, a hostname-based service, and along with a port range of 22 for low and high, limiting this service only to SSH. Next, we create the host v1 config, and here we are setting the remote address that we are going to connect from the remote router to 172.16.240.129, which is the IP address of the Ubuntu server. And we're setting the protocol to TCP. And I do apologize, the output here doesn't show the actual port. The port is also set to port 22. My helper script just didn't display it properly. The next command that we show here is to create the service. And what we do here is with the -c option, we are assigning the intercept v1 config that we created and the SSH host config that we are, I'm sorry, the host v1 config that we created, and we assigning them by name. And then we are assigning a role attribute of router hosted to this service. The next command that we're issuing is Ziti Edge create service edge router policy. This is kind of a filter. Basically, in Ziti, you're able to filter which edge routers are allowed to reach a service. For purposes of this demo, we're allowing all routers to be able to reach that service. And basically the router that the edge router that would be need to reach that would be the local router. So we could have also assigned it specifically to this edge router, but for purpose of the demo, we set this to all, which basically allows any router to reach that server in the Ziti network. We set the service role to router hosted, which is identifies this is the service, and semantic was set to any of, which will basically say that if, for instance, we had additional service role attributes and or edge router roles, any one of them would apply to make a match. So the next command that we add is create service policy for the bind policy. We're binding that policy to host identities, which binds the remote router. And so that makes the remote router a host for this service. And then the service role is set to router hosted again, indicating the SSH service that we created. The last command is the Ziti Edge create service policy dial policy, which we're calling SSH dial. And the identity roles here assigned to clients, which assigns the identity associated with the edge router as a client or dialer of the service. And then the service is identified as router hosted again, which is our SSH service. And that has configured all of the service entries required to enable our simple SSH service between the Windows client and the Ubuntu server. So with that, before starting the router or the local router, I am going to go ahead and I'm going to go ahead and basically make a DNS query to show that without the router turned on, we cannot resolve the service, nor can we connect to the service. So look up and go ahead and grab the name of the service. All right. You'll see that we're trying to reach the router resolver, but he's not online right now. So that's why we're timing out. And so we can't resolve it. We also cannot connect to it. So now we will go ahead and start the router. You'll see that we set a resolver mapping to the first address in the 164.0.0 range. And we also set up a tproxy mapping as well as a ingress rule on the ENS33 interface to allow traffic in from the LAN port. So now we'll go ahead and issue the NS lookup again, and you will see that we now are able to resolve from the Windows 10 client the IP address associated with my simple service.ziti. And now we're going to go ahead and SSH. You see that we had a new session was received, which is also, we see a successful connection. And of course, we can see that in the fact that we have connected to the server. And we'll do an IP ADD now that we're here. And as you can see, we are connected to our Ubuntu server over the OpenZiti fabric from the Windows 10 client. And with that, I will end the demo. Thank you very much for joining.